pre-cal, it's time for examples 5 and 6. So more solving rational equations. Yay for us. Okay, very first step, we're going to factor everything that can be factored. So I'm going to factor this denominator right here. Okay, it's got to have two positives. Values that multiply to 6 and add to 5 would be a 2 and a 3. All right, so I am going to rewrite that. And now what we're going to do is we're going to figure out what domain restrictions we will have for this problem. A can't be anything that will result in a 0 in the denominator. So I'm going to set a plus 2 equal to 0 and solve. Okay, so a can't be negative 2. Going to set a plus 3 equal to 0 and solve. A can't be negative 3, and that takes care of it. If we get those as solutions, there's no solution or solutions, or we list them as extraneous solutions. Okay, the next thing we have to do is decide on the LCD. Well, the LCD has to contain an a plus 2, and it has to contain an a plus 3. That automatically takes care of this one and this one. Since no denominator has a plus 2 times a plus 2, we don't have to have a plus 2 twice in the LCD or a plus 3. All right, so I am going to now multiply my entire equation by a plus 2 and a plus 3. All right, so this whole thing gets distributed to this one and this one and this one. So I've got 3 times a plus 2 times a plus 3 over a plus 2 times a plus 3 plus a minus 1 times a plus 2 times a plus 3 over a plus 2 equals 7 over a plus 3 times a plus 2 times a plus 3. Okay, now we get to start reducing. Let's use a brighter color. A plus 2 and a plus 2, a plus 3 and a plus 3, a plus 2 and a plus 2, a plus 3 and a plus 3. Remember, if all of your denominators don't get marked out, you've done something wrong. Okay, so what do we have here? We've got 3 plus, and then we've got to FOIL this a plus 1 and a plus 3, so that gives me a squared minus a plus 3a minus 3 equals 7a plus 14, because I have to distribute my 7. All right, let's tidy this up and combine like terms. Well, that's all we have, because the 3's add to 0. Okay, so this is where this gets a little tricky. Notice that we've got a quadratic term, we've got a linear term, and a constant term. Since we're going to have a quadratic here, that means we move everything to one side. So we're going to have this equal to 0. So I subtract 7a and 14 from both sides. So I end up with a squared minus 5a minus 14, and you guessed it, we get to factor this little guy. I know you're all excited. Try to calm down. So a equals 7 and a equals negative 2. Well, negative 2 is one of our restricted values, so our only solution is a equals 7. So this would be considered an extraneous solution. So we have a real solution and an extraneous solution. All right, so let's look at number 6. I'm going to erase this right here so we've got more room. Okay, so we're going to start by factoring everything that will factor. So 2x minus 6 will factor just like this. This will factor into two binomials. And this will factor into that. Okay, so domain restrictions, x minus 3 equals 0. So x can't be 3. That is our only restriction. So my LCD, we have to look at our LCD here. Our LCD must contain a 2. It must contain an x minus 3. It must contain another x minus 3 because this whole denominator has 2 of them. Remember, our goal, right back over here, remember we had to make sure we got rid of the denominator. So since there are 2 of these, that means I need to be crossing 2 of them out. So I've got to have another x minus 3 in my lowest common denominator. All right, so this one is taken care of since this is already down here, and this one's taken care of, and then both of these are taken care of because there's 2. But I also have to have a 3 in here. So I'm going to tidy up this LCD so it doesn't look so horrible. So I've got a 2 and a 3 here, so that's a 6, and an x minus 3, and an x minus 3. That is my whole LCD. All right, so I'm going to rewrite my problem. So I've got x over, x over 2 times x minus 3 minus 3 over x minus 3 times x minus 3 equals x minus 2 over 3 times x minus 3. So I'm going to multiply this whole thing by 6 times x minus 3 times x minus 3. And it has to be distributed to every term. All right, so I start with 6 times x minus 3 times x minus 3 times x all over 2 times x minus 3 minus 3 times 6 times x minus 3 times x minus 3. I'm out of control. I know everybody's surprised. And then I've got 6 times x minus 2. Why am I right? Oh, I've just put that first. Dang it. Follow a pattern, Amy. Follow a pattern. Sorry, follow a pattern, Miss Griggs. Y'all are not allowed to call me by my first name. Okay. I'm exhausted. All right, let's pick a pretty color to cross these out in. All right, so x minus 3 and x minus 3 right there. This 2 will go into 6 3 times. This x minus 3, both of those cancel out. See why we had to have 2 in our LCD? That is the reason. Okay, x minus 3 and x minus 3 reduce. 3 goes into 6 2 times. Now we're going to tidy this up. All right, over here I've got 3 and x, so I'm going to write 3x, and that is going to get distributed to x minus 3. We'll do that in a minute. Minus 3 times 6 is 18 equals 2 times x squared minus 3x minus 2x plus 6. So we foiled those two binomials. Now we're going to tidy some things up. So I've got to distribute my 3x. So I have 3x squared minus 9x minus 18 equals 2 times x squared minus 5x plus 6. Now we can distribute the 2. So 2x squared minus 10x plus 12. And now this is a quadratic situation again, so I'm going to subtract 2x squared from both sides. I'm going to add 10x to both sides. I'm going to subtract 12 from both sides. This ends up with x squared plus x minus 30 equals 0. Excellent. All right, so we're going to factor this. X and x, 5 and 6, positive, negative. So x equals 5, x equals negative 6. Neither of those fall into the restricted values. So these are our two solutions. Magical. You've just got one more video, kids. Just one more.